Hi guys, welcome to Next Gen Student channel Thermodynamic video series. Today I am going to discuss Dehoff 10.9 question. So let's get started. So we have a regular solution with critical temperature and we need to calculate the following. So if you draw the miscibility gap phase diagram, we have alpha phase which splits into two phases, alpha 1 and alpha 2, and this is a T versus X phase diagram. We have the critical temperature at 746 Kelvin. Now we need to measure the results at 650 Kelvin, the spinodal limits. So if we draw G versus X curve at 650 Kelvin, we have an alpha curve where there is a common tangent. So here we should draw a curve like this, and the common tangents are at x1 and x2. So those are the points. And now the spinodal region is where we have a spontaneous decomposition. So those are the red points on the G versus X curve, and this is where if we start at this composition, the alpha splits spontaneously into alpha 1 and alpha 2. So how do we obtain the spinodal points? They are the inflection points, means the G, if you take the double derivative, we get that is equals to 0. So we will do the same thing here, and here the alpha 1 and alpha 2 have the same crystal structure. So for G versus X curve we have only one curve for alpha, but they have different solubilities of A and B components. So that is the only difference. Now for this question, we have delta G mix equals to delta H mix minus T delta S mix. Delta S mix is the configuration entropy, and for regular solution delta H mix is A x1 x2, which is a simple regular solution. Now we will write the whole formula, delta H mix and delta S mix, which is configuration entropy. Now for the spinodal limits, we need to take the double derivative equals to 0. So first we will take first derivative of this. In that we differentiate with respect to x2. We can differentiate with x1 also, but we do with x2 and we will know the benefit later on. So this is how the derivation looks like. So we are left with ln x2 minus ln x1. Now we take the double differentiation, which is nothing but the differential of the first differential. So again, when we take the differential, we are left with minus 2a plus RT 1 by x2 minus 1 by plus 1 by 1 minus x2. So at spinodal limits this differential is 0. So that is a plus sign. I have put minus up there. So this is a plus. Now we know 1 minus x2 is x1. So x1 plus x2. So we know x1 plus x2 is 1. Now what we are left is this quadratic equation. So we can take the x2 into 1 minus x2 from the denominator to the numerator and 2a from the numerator to the denominator. So we are left with this simple quadratic equation, and we know the values of A as 12,700 joule per mole. So for a quadratic equation we will use the algebraic solution, which is a simple solution. 1 plus 2 by RT. So this is the solution. Now that R is 8.314 joule per mole Kelvin and A is 12,700 joule per mole and temperature 650. So we substitute those values and we obtain X2 as 0.307 and 0.693. These are the spinodal points. Now we go to the second part, B part, where we have to obtain the chemical potential of P. Alright. So we already have differentiated with X2 once. So we will use this equation directly. So that's why I differentiated with X2, so that we'll have that benefit. Now I'll input that differential here. So this is the first differential of the delta G mix with respect to X2. Now I will expand the delta G mix and try to simplify this equation. So we have x1 ln x1 cancelled and we have x1 is 1 minus x2, so minus x2 and plus x2 ln x2 cancels. So we are left with RT ln x2. Now we try to expand this formula. So we are left with a x1 square plus RT ln x2. So that is the delta partial delta GB, that is the chemical potential of B. Now we have to take the differential of this for the C part. So that's nothing but the second component. So I take the differential and we obtain a very simple equation, and we substitute the values and plot the diagram. Thank you for watching this video. If you like the content, please click on the like button and subscribe to our channel. Also, please press the bell icon for further notifications. If you have any content that you would like to see, please do comment below.